Now let's look at case number 2, wherein object A is with initial velocity. For example, here this is the object A, and then the object B is not moving, so this one is at rest. And then after that, the final would be after collision, either one stops or moves in opposite direction. So we could have like A stop, and then the B will gonna move, or A will gonna move in opposite direction as well as this B. So that would be our case number 2. Now if we're gonna look at problem number 1, a 4 kilogram bowling ball slides to the right at 8 meters per second, has an elastic head-on collision with another 4 kilogram bowling ball initially at rest. The first ball stops after collision. So if we're gonna look at our problem again here, we have to find the final velocity, but we need to state first the given. What is the given here? The given for the mass 1 would be 4 kilograms with an initial velocity of 8 meters per second. Next, our mass 2 here is again 4 kilograms with an initial velocity of 0 meters per second. Why? Basically, that would be at rest. And so our required here, so what is the required? The required here is the velocity of the second ball after collision. So we have here the velocity of the second ball final. So that would be the velocity of the ball, the second ball after the collision. And so if we're gonna think of our problem, this would be the case that we have here the ball A, and then it is traveling at 8 meters per second. So this one, the ball B, is at rest. And then after that, after the collision, what happens here is that the first ball stops, so this one stops, and then the B moves in the right direction, and we don't know what will be the final velocity. And so by looking our equation here, looking our general equation, since it is an elastic collision, so we have here elastic head-on collision, we can assume that we could use the formula first of M1 V1 plus M2 V2. Of course, it's optional if we could write the initial conditions, and then that would become the M1 V1 plus M2 V2, and of course we're gonna have the final condition. And so we could see here that if we're gonna plug in everything first, let's try to plug in everything first. The M1 here is 4 kilograms, and it has a V1 of positive 8 meters per second. Now take note here that the M2, we have the velocity wherein we have the mass 2, which is 4 kilogram multiplied to 0 meters per second, and then this one will definitely cancel out because that would, anything multiplied to 0 is 0. And so we have here also the M1, which is 4 kilograms, and then since it stops, so that would be 0 meters per second again, and that would be plus the VF, which is 4 kilograms, and then we are looking for the value of VF, or the V final, or the final V2F. Okay, and so we can simplify now here our equation. That would be 4 times 8, that would be 4 times V2F, And of course, that would be V2F, divide both sides by 4, cancel it out, and the velocity is 8 meters per second. Okay, now, if we're gonna look here, this one is positive, and simply because the velocity represents going to the right. And how about for letter B? For the letter B equation, now let's gonna look on the letter B. This one is just a proving method for letter B. Let me just have it here. Let me just make it smaller. Okay. And so for the letter B, take note that the kinetic energy for both of this, we just have to prove it. And then we're gonna have 1/2 m1 v1 square plus 1/2 m2 v2 square is equals to 1/2 m1 v1 square plus 1/2 m2 v2 square. So this one is the condition for the before or the initial, and so this one is the condition for final. And so we could have it here that this one is 1/2. The M1 is in 4 kilograms times 8 square. And so for this condition, the velocity here is 0. So this one can be cancelled out. And also this. So we can also have 1/2 and then 4 for the second times 8 square. Now notice, this one, they have an equal value, right? So they're gonna have an equal value here, and so this one we're gonna consider as no energy loss. So this one is a perfectly elastic condition. So for letter B, these are verification. We calculate the total kinetic energy before and after collision, and that means that this is an elastic or perfectly elastic condition. So basically, there is no kinetic energy loss.